The cosine law can be used with triangles that don't have a 90-degree angle. As you can see, on the triangle on the left does not have a 90-degree angle. It's not a right triangle. So there's two forms of the cosine law, and one form we use when we are looking for a missing side. So we would use lowercase c squared is equal to lowercase a squared plus lowercase b squared minus 2 times a times b times cos of angle C. And it's very important that the side that we're looking for, so side C, lowercase c, and the angle that we are looking for are in the positions that I've underlined in the formula. So this is what we use when we're looking for a side. And notice that angle C and side C are across from each other. Now, the other form of the formula that we can use, and it's just a rearrangement of the first form, is cos C is equal to a squared plus b squared minus c squared, all divided by 2 times a times b. And again, in this case, it's important that the cos of the angle C and then the side C are in the positions that I've indicated. So the second formula we use when we're looking for an angle. So let's get to our examples. Our first example, we are going to be solving for side A to 1 decimal place. So I'm going to finish labeling the triangle first. So side A is across from angle A, side C is across from angle C, and side B is across from angle B. So we are looking to find side A. Now this case for the cosine law is sometimes referred to as side angle side, because we have a side, then we have an angle, and then we have a side, all in that order. So side, angle, side. And just a reminder to look back on the notes for this unit, and it will give some more detail about that. So we've labeled everything, and notice that we're not looking for side C. If we move back up to our formula, we have it all rearranged to look for side C. We're looking for side A. That's okay. We can still write out the formula. We just have to switch around some of our letters. So we have a squared is equal to b squared plus c squared minus 2 times b times c times the cos of angle A. So notice that we have side A by itself, well, side A squared by itself, and then over here at the end we have cos of angle A, and that those two pair up. So the next step, we are going to put in the information we know. So we know that B is 32. We know that C is 40. So we end up with a squared is equal to 32 squared plus 40 squared minus 2 times 32 times 40 times cos A. So cos of 58. Okay, so our next step is we're going to simplify a bit. Now, many of you can actually just write down the formula, do all your substitutions, and then do it all in your calculator in one go, and that's great if you can do that. Some people will like to write out some more steps before they do that, though, so we're going to do that. So 32 squared is 1,024, 40 squared is 1,600, and we have this big chunk at the end, so 2 times 32 times 40 times cos 58. Now, we don't want to round until we absolutely have to, so we're going to just start out by multiplying these three numbers together. So 2 times 32 times 40 gives us 2,560, and then we're still multiplying that by cos 58. So if we punch cos 58 into our calculator right now, we're going to get a big long decimal, and we don't want to have to round until the end. So we can do one more simplification where we can add these first two terms together, and we get 2,624 minus 2,560 times cos 58. So 2,560 times cos 58, that is one term. We cannot split that up. So now it's time to put it all into our calculator in one go. And when you do that, you need to make sure you keep this together. So for a squared, you should get approximately 1,267.406 and so on. So I'm not rounding. I'm still keeping this number in my calculator. And we need to get a by itself though. So that means that we have to take the square root of our 1,267 and so on to get a by itself. And you should get that A is approximately 35.6 meters. And notice again, we're rounding our side lengths to one decimal place, just like we've done before. Let's do one last example. Okay, so we're going to do example 9. So if I can zoom in here. So in example 9, we are going to be solving for angle B and rounding to a whole number. So we have on our diagram here, we have all of the sides and angles already labeled. We don't know any of the angles, so truthfully, using this information here, we could solve for any angle, but we're just going to start off by solving for one. So this case is sometimes referred to as side, 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 because we have all of the side information but none of the angle information. And that's okay, because we have a formula we can use to find the measure of one of the angles, and we have all of the sides. So in this case, we are looking for angle B, so we want to label our formula accordingly. So we have cos of angle B is going to be equal to a squared plus c squared minus b squared all over 2 times a times c. So notice here we have cos of angle B, and then we are subtracting side b squared. So those two need to match up. Next step after our formula is to put in the information we know. So we don't know what b is, or angle B. Lowercase a is 4.0. Lowercase c is 1.8, and lowercase b is 4.3. So now we have cos of b is equal to 4.0 squared plus 1.8 squared minus 4.3 squared, all divided by 2 times 4 times 1.8. Now, many of you can punch that all into your calculator at this point and solve for angle B. But for those who cannot, or you're just not comfortable doing that, let's do some more calculations to simplify it. So cos B is going to be equal to 16.0 plus 3.24 plus, whoops, we don't want plus there, we want minus 18.49. And all of that is over 14.4. So we need to simplify everything that's on top and solve for B. So what we're going to do is we are going to take the cos of the inverse, so we write it as cos to the negative 1, and now we're going to add everything on top together or subtract. And when we do that, we get 0.75, and all of that is all over 14.4. Okay, and we're going to punch that into our calculator, and that's going to give us an angle B of approximately 87 degrees. So remember that we are rounding angles to the nearest whole number.